So yes, welcome everybody to the devcord topic of the month, week 2. Thank you very much for joining us. What's happening this week? We're having a slight change in format from last week. After some feedback from you guys, we found out that Discord's compression absolutely murdered the readability of text, so that kind of rules out the live coding sessions. So we're going to be moving to a lecture-style format. We're going to be doing more sort of deep dives into specific topics. We're just going to scrap the code streams. Because realistically, who wants to watch someone write code for an hour, 90 minutes? It's just not particularly entertaining, and you don't really absorb much information. So instead, we're going to do Q&A style things with with some lectures. We're still going to be taking requests if there's a particular topic that you want us to go through. If you've got some questions, just in general, for me or the staff or anybody else's topic of the month, please do ask away in live stream text. Like I say, I'll be keeping an eye on it during the stream. If I do miss your question, please just ping me and I'll take a look at it as soon as I can. The GitHub repo for the template repo rather for this project, the one that everyone's basing their APIs off. I've been making a few changes to that over the last couple of days. I've added some documentation to it, and I've added some continuous integration via GitHub Actions. So if you want to submit some changes, just open a PR for it and it'll build it and tell you whether everything's okay. And hopefully the documentation will lead you in the right direction how to actually get started. Thank you very much to ShammerCon for harassing me to write the documentation. It is now in progress. It's not complete yet, but there's enough there for you to actually get started. So what's been covered this week? We're going to be covering how to use Postman like a pro. Postman is my lifeblood. I absolutely love this tool. I use it every day. We're going to go over how to use it effectively, leveraging some of its features. We're going to be using things like pre-request scripts for automation. We're going to be looking at collections to smooth out the dev process, especially among a large team. And we're going to be doing a really quick rundown of headers because there was a few people who didn't quite understand what headers are and what they're for in the last stream. We're going to be taking a look at why we hash passwords. We're going to be looking at what hashing is, why we do it, and some of the thinking behind it. We're also going to be looking into WebSockets versus HTTP requests, when, where, and why, and some of the drawbacks and some of the advantages of using WebSockets. So we're going to jump straight in. Testing your API, how to do it effectively, looking at a couple of clients and tools. There's the aforementioned Postman. Again, I love this tool. It's a super easy to use GUI for putting together really complicated HTTP requests. It's got collections in it, it's got environments, it's got pre-request scripts, and then there's Insomnia, which is kind of Postman's biggest rival. I don't really use Insomnia. I'm not a particularly big fan of it, but as far as I'm aware, it has feature parity with Postman. So everything you do in Postman, you can do in Insomnia, as far as I'm aware. Another alternative would be Postwoman, which is kind of like Postman. Again, it does the same job, similar sort of layout, but this time it just runs in the browser. There's no Electron app to install, which is wonderful if you can't bear facing installing yet another Electron app. So first up, we have pre-request scripts. These things are amazing. They run before your request. It's basically just a block of JavaScript, however complex you want it to be, and it will run before your request gets sent. One of the main things that I use these for is authentication and authorization. So for example, before you actually send the request off, you could make a request to the login endpoint and you could get a JWT before you actually fire the request. For bonus points, if you have a refresh endpoint for your JWT, you could hit that instead. Global and environment variables play a really big role when you're working with pre-request scripts. These can store data that can be used in other parts of the Postman client. So for example, if you set a variable for an access token or like a JWT, you could use the pre-request script to go and obtain a JWT and update that environment variable to reflect the new value you got back from the API, which you can actually see in the screenshot there. And it can also make requests, because sometimes you just want more requests with your requests. Next up is collections. These are just glorified folders, but they are amazing. Again, so it's a glorified folder. You can save requests into a collection. So if you're getting fed up of typing out that same JSON body for a request over and over again, save it into a collection. You never need to do it again. You can apply pre-request scripts to a collection, and these will apply to every request in the collection by default. So for example, if you have a bunch of endpoints that are allowed to be hit by guests and a bunch of others that are only allowed to be hit by authenticated users, you could make two collections. One of them has a pre-request script to go and get a JWT for every request. The other one just doesn't bother. These are exportable and shareable. This is the main reason why these are so powerful. If you're working with a large dev team and there's a lot of different people using a lot of different bits of tech, for example, but they're all hitting the same API, you could distribute one of these collections out and they could start testing with them. One of the other amazing features about these is that they are version controlled. So there's Git-like versioning inside each collection by default. You can actually fork a collection, make changes, and submit a pull request so your changes go back up to the main collection. These things are absolutely fantastic. Even if you're not working in a team, definitely start creating collections and definitely start filling them full of requests. And finally, we come to headers. These are incredibly important when you're working with APIs, when you're working with HTTP in general, really. They make up the top half of the request, which is probably why they're called headers. If you look at the raw data for a HTTP request, you'll probably see that there is a ton of key value pairs up at the top, and then there'll be a dividing boundary, usually a set of dashes, sometimes it's like a hash, and then at the bottom there'll be the actual request body itself. So if you're sending a post request, that will be where your data appears. You've got different kinds of headers that do all kinds of different things. For example, the content type specifies what you're sending to an API. You also have the accept header, for example, which specifies what you want back. And you also have the authorization header, which is used for specifying your tokens and will allow you access to authenticated endpoints on an API. Oh, I was wrong. One more to go with Postman. We have environments. These are exactly the same as environments that you would set up in your code, except it's just in Postman. They allow you to set environment variables. You can also update these via pre-request scripts. You can also change these manually if you need to. You can have as many of these as you want. It's very useful when you're working on a lot of different projects that require a lot of different things to be set. For example, I've got a project that does some behavior based on the origin header, and I sometimes need to be able to modify that origin header, so I have a separate environment set up where that origin header is always set to a fixed value. And that's the only project where I need to do that, so I just create an environment for it instead of changing that on every single request. Yep, there we are. Useful for storing settings that are specific to a project. So now that we've absolutely blazed through the Postman bit, hopefully everybody caught everything that you needed in there. If you do have any questions, please do just hit me up or ask in voice. Otherwise, we'll move on to password hashing. Now let's give it a second here for any questions to roll in. Okay, looks like we haven't got any questions. That looks like a good sign. So we'll move on to password hashing. This is unbelievably important to get right. It's the kind of thing that you will implement on day one of a project, and you will continuously battle test it the entire lifetime of the software. Just keep throwing data at it, make sure it always does the right thing. If you give it garbage, it's supposed to reject it. Every single time, continuously test this. As for what hashing actually is, it uses the magic of mathematics to make attackers sad. And it does that by using one-way hashing functions. Now, as best way to describe a one-way hashing function is it's something that's easy to compute forwards, but it would take thousands of years to compute backwards. An example I'm going to steal from Tom Scott, which isn't the best example, but it's kind of a good one, is if I asked you to multiply two prime numbers together, no problem. You can just go straight forwards, done. But if I was to say, what two prime numbers do you multiply together to make 161? Suddenly everything just completely falls apart. You have to resort to what's known as a brute force method. So you start iterating through constant permutations, trying endless amounts of different values to eventually get to that result. In essence, the same thing is what's needed to crack a password hash. And I know it's a little bit taboo to discuss things like this, but it is one of these things that we need to be aware of when we're building backend services in particular. Popular algorithms for password hashing include bcrypt, scrypt, and pkbdf2, which I can never say straight. It's one of those that you'll see this all over the place. You'll know what it is, but you can't remember what it's called. I can almost guarantee it. Just in case I didn't make this point clear enough during my last stream, never ever under any circumstances in any scenario on any project for any client do you store plaintext passwords. Never. There is never a single scenario where this is okay. You do not do it at all. If you need a screenshot of this slide, please do take now. I'll be explaining why in just a second. Funnily enough, now. But why? Now we get to the serious stuff for a second. You need to keep your users safe by preventing easy access to their data. In this instance, we're going to assume that you are building a service which houses a lot of private data which these users do not want out in the wild. That means security needs to be paramount for you. Remember, you are an engineer. An engineer's prime directive at all times is to ensure the safety of the people using the thing they build. Just because it's software doesn't mean you're not an engineer. So you need to perform a shift in thinking. You go from, well, an example that I give to a non-technical client sometimes is you need to shift your thinking from equipping your car with flamethrowers to keep your phone safe to taking your phone out of the center console. It's a safety net, is password hashing. It minimizes the damage that can be done to that data after a breach. In essence, what you're trying to do is you're trying to protect the data when it's no longer under your control. If you work under the assumption that you are constantly under threat of somebody getting in and dumping out your database, you're going to start thinking about things a bit differently. So the main idea behind hashing a password is that that value is useless, unless tens of thousands, hundreds of thousands of years worth of compute time go into it. That hash is useless. And that's why we do it. So we've got a couple of questions I'm going to just have a quick look at before we go to the next slide. But attackers can steal our cookies. If they grab the secure cookies, they can enter the account. How do I protect the account? I think just off the top of my head, I had a thing for that, but I can't actually think what it is. I'm going to have a quick look at that one for you, and I'm going to post that one in the resources afterwards. I know a really good article that explains what's going on there. Can we invite some folks from Equifax? Yeah, there we go. So now on to some more practical stuff. How exactly do we hash passwords? For starters, you need to find an up-to-date guide for your language. The guidance for hashing passwords doesn't change all that often, but it's very important that you're on top of it when it does. The official docs for a language typically include information on how to do this. All else fails, Google is your friend. Start filtering results down by day or just ignore results that are older. And if in doubt, you can always ask the help section here on devcord. Avoid MD5. Avoid this like the absolute plague. MD5 is a hashing mechanism that was completely blown apart years ago. You can take an MD5 encoded string, you can put it into Google, and the first result will be the actual reverse of that hash. It will be the value that was hashed with MD5. That is how badly blown apart MD5 is. If the guide that you are reading suggests using MD5, run away. Find something else. bcrypt, scrypt, pkb, the other one. There are so many other ways that you can hash a password. If you see MD5, you need to completely close that tab and run away. So there's a question, what about Argon 2, and isn't pkbdf2 vulnerable to GPU brute force? That's the first I'm hearing of that, actually, vulnerable to GPU brute force. Argon 2 is another one which has been really coming up in the scene lately. I just didn't really think to include it in these slides. But yeah, Argon 2, very good choice. I think PHP was moving towards that. Didn't they move towards that in, was it 7.2? Where they started to integrate Argon 2? So yeah. And never ever email a user's password to them. Even if it's going to be hashed, even if you've just got the value in memory for a second, just before you run it through the hashing function, just don't do it. Do not email that password. The reason why you don't do that is that email is inherently insecure. Even when it's running through TLS and all this kind of wonderful stuff, man in the middle still happen. Email servers have all manner of problems that are constantly being uncovered. So just do not send the email with the password in it. Because most of all, you can't guarantee there aren't people listening in. Even if it's GPG, I wouldn't send it. I just, as a matter of principle, I would say do not send that password in plain text. It should never leave your system in plain text, ever. It shouldn't even be in your system in plain text if it's not immediately being hashed. The attackers can check out websites with Nmap to check vulnerabilities they can exploit and have access to the servers. Yes, this is what I mean with hashing passwords. If you work under the assumption that they are already working their way in, you need to start thinking about how can you mitigate the damage if they take the data out of your server. So if you've hashed the passwords, they can't use the hashes for the passwords. They can start trying to crack them, but good luck doing that in any reasonable time frame. But ultimately, yeah, the threat of being breached, it's always there. Assume it's always there. There's no such thing as perfect security. Should we hash only the passwords and also the emails? Usually you only have to hash the password. If you want to be really nice to your users, encrypting the data is never a bad thing to do. It might add a little bit of processing overhead, it might slow things down a tiny bit, but encryption's good. And I just want to draw a distinction there as well between encryption and hashing. Encryption is reversible, hashing is not, as a general rule. You have to brute force hashing to get backwards to the actual value that was hashed in the first place, but with encryption you can provide a key and just easily come backwards. So a very important distinction to make between those two. So I'm going to look at some of the other questions coming in. Where are the reasons bcrypt is so popular? Yeah, I think been built into PHP was, I think that was a big push for that as well. PHP natively supports bcrypt. The password hash functions, well, the password hash functions were using it up until, I think it's 7.2, and then they switched over to Argon 2 by default. More important, do not enter open Wi-Fi areas. I'm expecting an ad for NordVPN to start playing any minute. See, I called it. If that's all you got for the questions, I'm going to move on to this super quick rundown for WebSockets, and then we'll go into some Q&A. If hashing can be cracked by detecting the prime number, why can't it be thought of as encryption? Where is it also reversible given a key? I think you've slightly misunderstood the example that I gave. So the example was, if I ask you to multiply two prime numbers together, you can do that absolutely no problem. It's a super simple operation to do going forwards. But let's say that I ask you what two prime numbers do you multiply together to make 161. There's no easy way for you to go backwards with that. So what you have to do is you have to keep going forwards, and you just have to brute force it. Keep going and going and going and going until you stumble across the right numbers for it. It's not a perfect example because, of course, there are some mathematics tricks. There's some unbelievably smart people in the field of maths that could probably do that like that, but you get my point. It requires brute forcing. So in this instance, hashing is kind of following the same principle, just more. So it's an easy function to run forwards to generate the hash, but it's not an easy thing at all to go backwards from the hash back to the plain text. The rainbow table can reverse a hash. Hash simply doesn't have enough info. A hash can reverse... a rainbow table can help with reversing a hash, but only if the value that the hash was created from is in that rainbow table. Yes. Because then you can just take the value out of the table, run it through the same hashing function, and then compare the two. But yeah, not perfect. Still requires a lot of compute power, still requires a lot of time. So the general idea is to slow them down as much as possible, which is what hashing is all about. So it looks like you guys are having a discussion. One from Austin. Oh, he was answering a question. Okay. So I'm going to move on to this quick rundown of WebSockets. Yes, you knew this image was coming. The fun thing to tell a lot of people is that WebSockets and HTTP requests are pretty much the same thing. The only real change between a socket and a HTTP request is the behavior. So a HTTP request, the general flow, not going into all of the countless hundreds of steps that are involved in TCP, you open a connection, you send and or receive some data, you receive a response, you close the connection. That's the standard flow for a HTTP request. Now if you look at WebSockets, it's a little bit different. You'll see the difference in just a second. So you open the connection, you send and or receive some data, you send and or receive some data, and that just keeps going and going and going and going. So the bit that's kind of missing there is that it doesn't close the connection. The general idea being you open the connection once, you just constantly send messages backwards and forwards, and then you close the connection whenever you want later on, unlike a HTTP request that closes it the instant it's done. And that makes WebSockets rather powerful. So how they actually work: opens the connection and doesn't close it. That's pretty much it. At the highest level, that's basically it. There's a lot more to it, but yeah. The way that data flows backwards and forwards is through messages. So both the client and the server are pretty much directly connected to each other. They can both, I think the model name for it's called PubSub. So both sides are capable of publishing and subscribing to the other side. So you send and receive messages backwards and forwards. The messages can contain data, just like a regular HTTP response would. But sometimes, which is a thing that I quite like to do, is I send an empty message, and the message doesn't actually contain any data, but the message being sent does actually mean something. But in that instance, you're looking a lot more at things like context. So when I say an empty message, I just mean that it doesn't contain any actual data. It does still contain a string, which is usually like, it's usually some kind of message type identifier. So if I was to say something like, the client sends a message saying request send, and then the API might send something about like request send acknowledge, and you can basically replicate TCP with it. So what WebSockets are actually good for: do you need to go fast? Because WebSockets are fantastic for quote-unquote real-time communication. I say quote-unquote because there is always that one person, usually me, that points out that real-time is, that's a whole other ballgame, is that. Actual real-time communication without all the latency involved of electrical signaling and components and stuff, it's, don't open that can of worms, really. It's, call it real-time. You could probably sell it to a client as real-time, yeah. But it's not real time, if you just want to be that guy, which I usually do. So there's no overhead from opening and closing connections. Every time you need something to happen, you just fire a message. And the same goes for the other side of that on the API. So regardless of whether it's client or server, you want something to happen, you fire a message. It's also really good for rapid-fire requests. So if you've got a ton of small requests that are firing all the time at really unpredictable intervals, WebSockets are great for this. As long as you've got some super efficient code on the other side that can process it, it's wonderful for this. One particular example that I implemented on a side project was a progress bar for a really complex batch operation that was going on another service. So the client requested the job, the API started processing the job, API passed off the actual data to be processed onto another service, which is written in .NET. .NET does its blazing fast multi-threaded awesomeness, and it just constantly spams WebSockets back at the client, WebSocket messages, and the client just passed these messages and just filled up a progress bar. And that was really good because every single message that came back, I needed them all to be unique because each piece of data was significant that was being processed. So in that instance, WebSockets shined. Oh yeah, like Discord. Discord uses WebSockets, Slack uses WebSockets. Sometimes you've got channels going absolutely crazy. Can you imagine trying to open a HTTP request every single time you're going to send a message? You'd end up running out of memory and 10 messages flat. Persistent connections. This one is kind of similar to rapid fire requests. So it's things like dashboards and charts are things I've used these for. It's really good when the information doesn't need to be constant. So you don't need this constant flow of data coming in and out, but you do need to react to it immediately. Data comes in, bam. I can't wait for the connection to close and then start getting the data out and processing it. Nope, I need it now, immediately. And got a question. What's the difference between a duplex RPC connection and a WebSocket connection? I think you are well outside the scope of this topic, my guy. Yes, I couldn't tell you, unfortunately. I don't know. So we've got... I would say we've got another slide, but it looks like Google Presenters crashed. There we go. It came back. So these disadvantages, it was actually kind of tough to put this together, this very short list, but it's all based on purely subjective things that I've noticed. With a WebSocket, because it's event-driven and you're doing everything after a connection, it usually ends up in one enormous block, and it tends to get really unmaintainable really fast. But that's it's more of a code style issue than a technical issue. It will still work. It will still work absolutely wonderfully, and it will be blazing fast. But it's going to be this huge block of code that you have to try and deal with and maintain. So abstraction, abstraction, abstraction. That will help you there. If you want to use multiple sockets as well, you're going to need multiple of these massive blocks. So this can make things a little bit tricky if you're trying to separate things out on different sockets. The way I tend to do it, I'm usually super lazy. I have a single socket, and every single message that gets sent backwards and forwards has a message type identifier on it. And then it's just a massive switch statement, instantiate a service, do the thing. That's my super lazy way of doing it. I'm sure there's so many different better ways of doing it. If you do know of any, please do link them in the backend chat, and I'll go check them out because I want to use more sockets. It's been a while since I've last done that. The next problem, which I've run into a couple of times, if you are writing some particularly expensive or computationally heavy logic to handle a message, you can really quickly just jam the whole thing solid. The amount of times I've done this on the client side, it's ridiculous. Especially in Angular. Angular's built-in WebSocket stuff is... It does a great job of connecting, passing messages. It's just terrible when it's actually running your logic. I just had browsers completely freeze solid and you have to for sig kill and all that. It's not great. Be careful what you respond to with WebSockets. That's why I use the message type discriminator on every message that I send and receive. So I can switch through and see if there's a match for these cases I specifically care about on a WebSocket. If there's not, I just drop it. Otherwise, I instantiate the right logic and off we go. And I think that's it, actually. That's the end of my slides. Does anybody have any questions? Please do hit me up in voice. I'm at the end of my slides now. What WS server framework do you use? I don't actually tend to use any framework. It tends to be something that I just build into an existing application. I'm usually just using the WS package because first Google result. I think I might have to check this one out. I need to do more socket stuff. I need some socket projects to work on. If WebSockets are so great and so fast, then why haven't sockets replaced HTTP requests? The issue is that you don't always want a WebSocket request. Sometimes things like making a single response, getting some data, making a single request, getting some data and then processing it, that's better than it is opening a connection and then listening for that one message which might have the right data that you want and then closing that connection. Because at that point, what you've done is you've recreated a HTTP request with extra steps. What are some apps that use WebSockets besides Discord? Probably the other most notable one I can think of is Slack. You'll find them all over the place when you start looking for them. I think GitHub uses sockets on the pull request page. So if somebody pushes a change to it, the socket fires a message and the page updates to let you know that it's outdated rather. As for creative ways that people use them, I've not really seen anything that stands out. I've seen some truly wonderful implementations, like some really efficient implementations of stuff like handling lots of data just streaming in. But as for like novel creative ways, I'm not entirely sure. WebSocket is mostly useful when partial answer to a request still holds meaning. Yeah, I think that's a pretty good way to put it. Is it possible to use both WebSockets and HTTP in a single application? Absolutely. I've done that on a lot of different projects, where the vast majority of it is done just through a standard RESTful API, and then there's usually like WebSocket endpoints that are built into it. That's for, like on that side project I told you about, that I had that progress bar. That was an example of sort of a hybrid, I guess you could call it. So the vast majority is a RESTful API, and then there was WebSocket stuff like this one specific component. What about WebRTC? Why choose WebRTC over WebSockets? WebRTC is kind of in its own ballpark, really. I'd put RTC more in the realm of... It's more like interfacing with hardware, for example, like capturing input from a microphone or a webcam, things like that. You could potentially take data from WebRTC and then send it over a WebSocket, but it's just kind of two different ballparks. They're doing different things. What's a good way to get started learning how to use WebSockets? I would have a look at some of the NPM packages, like WS. Set one of those up and have a go at building yourself like a little real-time chat. That's how I did it, just when I was messing around with it. I'll post the link to the repo for that, actually, in the resources. So then you can have a look at how I did it. My very crude, dirty implementation. Try getting real-time data from a database. Not that again. I've been asked that before. No. The way you do it is you periodically do this massive query and you shove it all into an enormous Redis cache and just pull from that. It's quote-unquote real-time. Oh, you're using Mongo events. Oh, my sympathies. Ugh. And if ChainStream was an actual reliable stream, yeah, it'd be great. Do you mean there that HTTP would be like raw TCP, WebRTCs? Oh, no. Never mind. I misread it. Yeah, I think that's a pretty good way of putting it. Do we have any more questions? I'm just going to mute myself really quickly while I take a drink. Favorite color, blue, every time. Do you know about Quick? The name rings a bell, but I can't remember what it is. I will read the article though. That sounds interesting. You have more than one question in regards to the hashing part. Fire away. Could we go through making a Postman collection? Honestly, the screenshot that I showed you, it just kind of shows the whole thing. You just go to the collections tab, click new. There you go. Doesn't really make for a great demo. What are some of the pitfalls of WebSockets you've run into? The biggest one was when I got a little bit too ambitious dealing with a hell of a lot of data coming back in over WebSockets. That was, again, that project that had the progress bars on it. I was trying to do way too much like drawing. I was basically rendering stuff, filling up a progress bar, and it got to a certain point where my machine just completely ran out of memory, basically. Firefox completely locked up. So if you're dealing with large amounts of data, having a way to sort of buffer it is absolutely essential. And then you can sort of process it at a more sensible speed. How to protect from an airplane or satellite denial of service. Going through something like Cloudflare, which would mitigate the volume of traffic coming in. I presume by satellite denial of service, you mean a denial of service attack which is launched via satellite. Regardless, though, in that particular instance, with a denial of service attack, it doesn't matter how the data is transmitted, whether it's satellite, cable, Wi-Fi, whatever. It's all about the amount of traffic that's coming in. Because whether it's satellite, cable, whatever, it's all still TCP and UDP. And that still ends up being processed the same way. So the best way to mitigate against just denial of service in general is to sit behind a really big network that's capable of absorbing the incoming traffic and then shaping it away from you and just into a black hole, basically. So something like Cloudflare. Don't worry, mate. There we go. So you said that we should always test the hashing function or something of the sort. Why would we have to test if we use a library for hashing like bcrypt? I don't really mean test it as in sort of pull it apart and write tests for it. I just mean when you've built an implementation that uses that library to generate the hashes, it's worth going back to it periodically, especially when something changes, like your, like say your login functionality or registration functionality. It's worth going back periodically and just making sure that it's still accepting the right data, it's still verifying hashes properly. Because getting that wrong can be disastrous. I'm not understanding the relationship between WebSockets and the protocols. I know the difference between TCP and UDP, but I don't get the connection between WebSockets. WebSockets are... it's TCP. So it goes through the whole handshaking and negotiation process, and it opens that connection, and then it just leaves it open. So it's kind of like... it's like TCP behaving like UDP. It's really clever. It's also really weird, but it's fascinating to work with. No problem. WebSockets is built on top of TCP, but it's had open frame protocol on top. It's pretty neat. I need to have a look into this quick thing. That sounds very interesting. Who's got questions? Keep them coming. How do I get a girlfriend? Ask George Foreman. Well, since we've been on the same slide for a while, I'm just going to kill the stream. We'll carry on with the Q&A. Is a hash sufficient, or should you really be salting things? Yes, you should absolutely be salting where you can. A lot of the time, things like the password hash function in PHP, that does actually generate a salt for you, and it takes care of that while you're validating the password as well using their built-in functions. For other languages and other packages, it all gets a little bit muddy sometimes. You're best off reading the documentation for those packages and just making sure that if there's an option for it, you provide it. Oh my lord, that's a lot of pings. Thank you, everyone. So if nobody else has any questions, then I'm going to drop off and I'm going to go make a cup of tea. What exactly is the salt and what role does it play in the hashing? That's a very good question. I really should have included that. A salt is like a mutator, so it adds more entropy, more randomness to make it even harder to try and what would be the term, to brute force that hash, because then you'd also need the correct salt to go with it. Although a lot of the time extracting the salt isn't actually difficult, it just makes it even more of a pain in the ass for the person that sat there trying to brute force the passwords. So I'm going to give it 5 more minutes and then I'm going to jump off. Just off the top of my head, I can't quite remember what point the salt's added. I've been spoiled by so many packages that take care of it all for me. I do believe that the salt is... Yeah, I do believe the salt's appended then hashed, but I'd have to double check that one and I'll get back to you on that. Sugar or not with green tea? No. Just green tea in general? No. Oh yeah, FJP, I have seen your question. I'll just get back to you in just a second. Right, so as a general rule with cookies, the way that I'd go about it, a secure cookie is basically a cookie that can only be used over a secure connection, so that would be HTTPS. The way that I tend to go about it is that I encrypt the contents of the cookie, and I tend to tie that to some form of identifier, which the user's machine... I've completely fluffed that explanation. So basically the identifier would be something that could only be generated from the user's machine, typically, I don't know, an IP address, something like that. There are more secure ways of doing it, but that is one way to do it. And then you'd bundle all this together and you'd encrypt it all. So if the attacker were to, say, try to decrypt it, they can't, because they don't have the key that's used to encrypt the cookie. And as well as that, if they start modifying the cookie, it'll just end up becoming garbage and you won't be able to parse it anyway, so then you just reject it. Never scripted Postman, have you used it that way? I don't use Postman as part of like a CI pipeline, but I do use Postman for just like generally testing. So I just manually put together requests and then just hit the API with them just so I can get some output from it and inspect it. In the collections view for Postman, there is actually a collections runner. So you can set up this... you can basically set up repeated runs of your requests, And you can also specify like little unit tests in there, so it'd be looking for things inside of each response, or it'd be looking for status code. You can basically write a custom test for it, and they are absolutely fantastic. They've saved me so much hassle over the past couple of years. But as for part of a CI pipeline, I would recommend you look into something like smoke testing. So the general idea with smoke testing is that you deploy the build, and then you'd run something like maybe a custom script, something that creates the HTTP requests and has a known response that it's looking for, just like a usual test, except you do smoke testing immediately after deployment. The term comes from electronics engineering, where smoke testing is you plug it in, did it let the smoke out? Same thing, but software. Yep, so I think that's everything. I'm going to jump off and I'm going to make a cup of tea. If there's any more questions that come in, I'll be answering them for a bit in text chat. Thanks for tuning in, everybody. I hope you enjoyed and I hope you learned something. And I shall catch you next week, Sunday at 9 PM BST.